Let me know whenever you're ready. Okay. All right. Can everybody hear me? No? Can everybody hear me okay? Is this working? I don't know if it's working. Okay. Hi, everybody. So welcome. Again, for anybody that came in past the welcome messages this morning, for anybody that doesn't know me, my name is Nikki Caboose. I'm the CEO of South Florida Tech Hub. I'm so excited to see so many of you here. It's actually kind of cool because when you're in session, I'm like, okay, I can't tell who's here because we're on all different floors. But then when you guys came out for lunch, it was a little overwhelming. So, but in a good way.
Just do this off the cuff. So my name is Radhika Aurora. I'm the head of enterprise tech recruiting at Schonfeld Strategic Advisors, aka Shonfeld, the presenting sponsor for today's conference. We're so excited to have the opportunity to sponsor this great event, to meet all of you, and wanted to thank Nikki and the entire Tech Hub team for all the work that has gone into putting this event together. Schonfeld actually moved to Miami formally last year and have loved getting integrated into the tech ecosystem through the work of partners like Tech Hub. Before I get into what, a couple of items. So first, our booth is the first booth on the left when you walk in. If you haven't already, pop by to meet the team so you can get to know us a little bit better and we can get to know you a little bit better as well. We also have a panel session today at 2:45, which will cover some trends in finance like data, cloud, and low latency trading. Now, to give you a little bit of insight into who Schonfeld is, I'll start with a quick overview. So Schonfeld is what's known as a multi-manager hedge fund. A multi-manager hedge fund consists of multiple specialized portfolio managers that have their own strategies and P&Ls. We started as a family office in 1988, and about 6 years ago, registered as an investment advisor. The latter allowed us to raise third-party capital. We invest our capital with both internal and partner portfolio managers, primarily on an exclusive or semi-exclusive basis across 4 trading strategies: quantitative or systematic trading, so using machines; fundamental equity, which is long-short discretionary. A lot of people probably would call it day trading in a lot of ways. Discretionary macro and fixed income, which is the same thing, but for macro and fixed income products. And then tactical, which is event-based, so like IPOs. We've created a really unique structure to provide global portfolio managers with autonomy, flexibility, and support to enable them to maximize their business. Now, obviously, technology is a huge part of that, but so is actually our culture. So just to give you a little bit of insight into who Schonfeld is, we are all about our people. Talent is our strategy, which you see everywhere, is our mantra, and it really drives how we approach all the initiatives at the firm. We believe our success is because of our people. So putting our talent above all else is our top priority. You might see a bunch of people in bright pink and bright blue t-shirts around, so don't hesitate to stop them and ask them more about our culture and why they work at Schonfeld. We also really differentiate ourselves in the market, not only through the recruitment of talent, but also through the development and advancement of talent. We aim to create an environment where our people can thrive. We foster a teamwork-oriented, collaborative environment where ideas at any level are encouraged and shared. We have a unique segment of the financial industry. So we have a dynamic platform, which you'll hear a little bit at a high level about from Yael later, that allow our investment teams to do what they do best. In the technology department, our day is filled with everything that a problem solver could ask for: intellectual challenges, strategic thinking, and issue triage. We operate at a global scale with startup agility, performing in the fast-paced theater of financial technology innovation. So what do we stand for in tech? Mobility, enterprise architecture, and engagement. Schonfeld's about 650 people globally, with about 200 sitting in technology. The majority of our technologists actually sit in New York and now Miami, since we are very much dedicated to growing Miami as a second headquarters. At a high level, our tech stack is C++ for latency-sensitive trading systems, Java for distributed, elastically scalable microservices, Python for data science, integration, and scripting, React and Go for our user interface platform, cloud-first container-based architecture orchestrated with Kubernetes, and obsession over automation through modern DevOps, SDLC processes, and infrastructure as code. And now to our keynote for today, which is being given by Yael Mayfield. She is our head of front office development, and she will be speaking on how to build high-frequency trading systems.
Excuse me for a second. I'm going to actually try. Can you hear me without the microphone? Is that okay here? Yeah? All right, perfect. That will make my life so much easier. And of course, this here. Okay. So, welcome everyone. I'm very excited to be here at the South Florida Developer Conference. This is my first time, but I hear it's the 17th year, so congratulations to everyone. I'm here to talk about how to build high-frequency trading platforms. But before I start, I'd like to get to know some of you, the audience. So if you don't mind to take out your devices and go into menti.com and enter the code that you see on the screen, 1530-6446. I'll give you a minute to do that. So jumping into the first question. Yeah, oh, sorry. It's also on the next screen, but go ahead. 1536-6446. The code is also at the top of the screen right here, if you missed it. First question, where did you come to the South Florida DevCon from? Wow, Arizona. A lot of people from New York. I'm guessing that they are all from Schonfeld. People from the area here, South Florida. I just moved to Florida last year in the summer, and I love it here, the weather. I even embrace the colors. I love the colors here as well. Everyone is so happy here. It's just great. All right, one more question. You can keep on doing it. We're going to move to the next question. Are you familiar with fintech, or have you ever heard of quant trading and HFT? Oh, quite a good distribution. I'm hoping that people that are seeing this streaming are also able to answer these questions. I expected actually a lot more not familiar at all, so it's good to see that we have quite a lot of a mix here. I hope that after this talk, you'll have a little bit more exposure and understanding of high-frequency trading. And the last question, did you know when you were 16 years old what career you wanted? Okay. Interesting. So I think I'm just like the majority of you. When I was 16-year-old, I did not know what I wanted to be. So a short intro. I grew up in Israel where military service is required. When I was 16-year-old, I received my first summon to come be tested. I wasn't sure what to do, and I was offered different programs, and I chose to go to computer science. And the program was 6 months of rigorous training, everything from operating systems, assembly, databases, networks, and languages that you probably never heard of, like PL1 and natural database, just to show my age. We used mainframes and DACs and PCs. When I finished that, I spent another 2.5 years in the service working on encrypted communications. I finished the service, and I decided to change my career. I actually wanted to be a vet. So I signed up to university, and after a couple of weeks before I started, someone told me about this great opportunity in New York. They told me you can go and work for the government, Israeli government, and you can study at the same time. And I thought, there must be excellent veterinary schools in New York. Why not? Let's go and try it. So I got to New York, I took the opportunity, and I decided to change my career. I decided back to go to computer science. So I went to university, I finished my computer science, and then I decided to look for another job. One of the companies I was talking to was an option market making firm. At the time, I didn't know options, I didn't know market making, and I had very little knowledge of the technology that they were using, like C++. They gave me a chance, and I decided to take it. And after mentorship and leadership, I learned both the business and the technology. And I fell in love because it was very fast-paced. I found that the challenges, technical challenges, were unique, and I really, really enjoyed it. Fast forward, we're not going to say how many years, but I'm still in fintech, and I still find it very, very interesting. So hopefully you will find it as interesting as I am. So today we're going to talk about the intro. We've done that. We're going to talk about the PM workflow. We're going to talk about what is HFT, and then we'll go into some of the challenges of building HFT systems. I will try and leave some time for Q&A. So let's jump into it. Radhika already told you a little bit about the fact that we have quant PMs that are using systematic methods for trading. How do they do it? First stage is signal research. They start with data, a lot of data. They can use 20, 30 years of worth of data to do the research and find signals or patterns in their data. It is a challenge by itself, all of that amount of data. How do we store it? Where do we keep it? How to make it available for users that can be very, very easily used to find these patterns? So I'm not going to get into these challenges, even though they're very interesting, but that's for another day. Our portfolio managers will use technologies like NLP, AI, machine learning to find those signals. Once they find the signals, they move to the next stage in which they're doing strategy development. They're taking all of these individual signals and trying to put them all together to find a cohesive strategy. That is called sometimes portfolio construction. As they're doing that, they're also starting to introduce real-time data to try and see how the historical data they use is fitting with their strategy. The next step is production trading. This is where we're using the high-frequency trading platform. I'm going to drill into that after this. The last step is the execution analysis. So they've done all this work, and now it's really trading. Are they doing well? Are they making money? Are they not? Do they need to change things? So they go back to the drawing boards, changing or finding more signals, changing how they do portfolio construction, and this cycle continues over and over again. The market changes so quickly that they have to go back and adapt. So let's go into HFT. What is HFT? I copied a definition here from Investopedia. I'm not going to read it. Fundamentally, this is how to use a lot of compute power to send orders very, very fast to the market. They say here fractions of a second. I'll get into it in a few minutes. Fundamentally, the main purpose is to get to the market as fast as you can. The faster you get, the more profitable you are. Okay. There are multiple ways to achieve it. Some firms do it with hardware. They would build FPGAs, and they get a very, very deterministic output. There is nothing that will make it slower or interfere with it. However, finding those resources that can build FPGAs is hard. The other part of it is the time to market. Doing all of that and burning the FPGA takes a lot of time. Another way is software, and this is what I'm going to talk about. Software has jitter. It's not deterministic as much as hardware, but this is the challenge that we are trying to face, right? How do we reduce that jitter? How do we make it deterministic? A short story about fractions of a second. A few years ago, I interviewed a candidate to help us build the high-frequency trading. And he knew everything about trading systems and about design patterns and algorithms and the language. At the end of the interview, I was really impressed. At the end of the interview, I asked him, well, what type of latencies can you achieve in your own system? And he was so proud, and he told me, we have great low latency system. We have about 100 milliseconds of performance. And I scratched my head, and I thought to myself, well, this is multiple order of magnitude from what we are looking. We are looking to achieve 10 to 100 microseconds, right? And he was talking about milliseconds. And I realized, just like this definition, they're saying fraction of a second, but everyone's definition of fractions of a second is different. So when we are talking about it, we're talking about the 10 to 20 microseconds. So when we're building an HFT system, what do we care about? Everything. The entire environment matters. This is like a building blocks. We go all the way from the bottom, the network and the messaging, to the host and operating system, the software, and the operation of the platform. I'm not going to talk much about the operations. I just won't have time, but just so you know, it's extremely important for us to stay in the market as long as possible and not get out of the market. So if there are outages, as fast as possible to recover. If we can build high availability, that's what we do. So the operations teams and the development teams are working very, very closely together. So let's start from the bottom, the network and messaging. Even if I throw away all the design patterns and everything I know about software and build everything on one machine, I still have to communicate to the market, to the exchange, like New York Stock Exchange. How do I do it? Via network. So no matter what, we have to have network. And network is considered one of the highest latencies components of systems. So what we do, we try to minimize it as much as possible. Here are some ways that we do it. First way, locality. What does that mean? We are trying to put our servers that are making trading decisions and the trading platform in the same data center where the exchange exists. Okay? That reduces the distance and the network latency between us and the exchange. Transport. I put here a couple of transports. These are by no means all transports, but these are what primarily is used in trading systems. And compare them, and again, this is very limited, but primarily, if you look on the right, the TCP, it's a reliable, guaranteed network. Think about if you're sending an email, you know that the other side will receive it unless you write the wrong address, right? The same thing here. If we send an order, we know that the other side will receive it in the right order of the messages sent. In order to achieve that reliability, TCP has multiple layers of acknowledging these messages, which means that it adds a lot of latency to it. On the other side, you have UDP. This is an unreliable network. Compared to real life, think about you're sending a message and either you get it or you don't. Okay, there's like send and forget. The other side might receive it, might not, and the sender doesn't know anything about it. So what do we use? Well, we use a combination. Certain things that we want to know that goes to all the way to the other side, we use TCP, right? I want to know my order always received by the exchange. Other data, we don't care if we miss some, so we use UDP. Some companies build things that are called reliable UDP. They create a layer on top of UDP in which if there are drops on the network, they can actually retransmit it. However, 99% of the time they use UDP and they get the benefits of the speed. I'm going to touch very quickly on message size. In general, in the network, there are very small frames that are going over the network. If you send a big message, it has to be disassembled to small messages or frames and reassembled on the other side. So what do? We try to limit our message as small as possible so it can fit there and you don't need to add that extra layer of disassembly and reassemble. Moving on to our next layer. Before that, one more question on Menti, sorry. And I'm also going to have a Q&A at the end, so keep that available. If you are able to choose an operating system for your applications, what would it be? Linux. I have to say, I'm not familiar with RTX. Who chose RTX? Anyone here? What is that? Okay. We might have to investigate that. Aye. Well, it looks like Linux is definitely the favorite here, and I would agree with that. Thank you for this. Moving to the next one. Next layer in our pyramid is host and operating system. I'm going to start from the first one, and then I'm going to get to very, very shortly to the others. But I want to start with where to run your application, in which your application stops working. So in terms of development and debugging, it is considered a much higher complexity. You can use multiprocessors to increase it. However, when you use multiprocessors, if you want to share data, you need to then write something or use other methods, right? You can use the network, message bus or just TCP, or you can use IPC, inter-process communication. In both of these, you actually have to write that layer to do it. We use, again, a hybrid. It's all about the benefits and the cost of doing things. When we run our application, we define what is called critical path. This is the path of the code in which we want to send the orders as fast as possible to the market. We reduce all functionality that is not required, and we try to avoid anything that can block our code, like writing to I/O that is usually can be blocking, or locking. However, we all write code. We all know that we need to debug our code at one point, so we have to do some logging, right? How do you write to a log file while you have that critical thread? Well, what we do is we use data structures that are non-locking data structures, in which we take the raw data as it is, and we just offload it to a queue. And then we have another thread that is reading that queue, and then it can do whatever it wants because it's not critical anymore. It can write it to a file, it can send it to the network, it can do whatever it wants. So we're using some kind of a hybrid. Then we'll have another process that can read a file and send it to users or have alerts on it. We use some kind of a hybrid. I want to tell a very short story about threading for my first job in finance. I started working there, and we were working on Windows machines at the time. And whoever designed the system, they really loved threading, okay? It was, at the time, it was a machine that had 1 core, maybe 2 cores. And we had about 180 threads running in this application, okay? You can ask yourself, what's the benefit of 180 threads when you only have 1 or 2 cores, right? Only 2 things can run in parallel. Well, I don't have an answer for that. However, the story is that it all worked well, and then it started to deadlock. It stopped operating altogether. And we didn't know what it was, and we started investigating. Again, code showed nothing. Multiple developers were looking at it, and it was all fine. We were lucky that one of the developers that we hired came from Microsoft. He was able to debug and find a bug inside the operating system that was causing deadlocking. So we actually had to upgrade our operating system at the time. So always think about the benefits of threading and multiprocess. How am I on time? Good? Okay. Well, I'm going to touch into that very, very quickly because I do want to give you all time for Q&A. Sorry. Architecture. How do you architecture your system? Are you using distributed? Are you using a monolithic? Again, we're trying to keep it as low latency as possible. Right? Most applications are using distributed design or architecture these days. Microservices is probably the biggest one, and there are huge benefits. Scalability is one of them. Each service is usually having a single responsibility that is easy to test, that is easy to deploy. And there are so many things that are great about microservices architecture. What's the challenges? Performance. By having so many microservices, you need now to connect them, right? You cannot have a trading platform that does only one small piece. So in order to get those connectivity, again, we're coming either to network or other types of communication, which are adding latency. On the other side, you have the monolithic. I'm going to write all my code in one application. It will be the magic application that does everything. All right. Well, what's the problem there? You have no latencies, right? It's all happening in one, and it's very, very fast. It's really, really hard to maintain. When you're making a change, now you have to go and test all of the functionality to make sure you didn't break something else in that application. It's not very scalable, right? How do you scale a monolithic? It's extremely hard. Again, we find some kind of a balance. We do not use a microservice architecture. For the critical, we try to minimize the amount of applications we use. And we try to find a fast ways to communicate, usually IPC. And everything that is not critical, we will use more of a microservice design in which application will have its own responsibility. So that's the dedicated resources to guarantee that when you have a command, it is getting the CPU that it needs. Okay. So this is one of the reasons that we are using dedicated hardware. We know for a fact that when we have a CPU, it is 100% dedicated for our application. Same with the memory. Of building our platform, we decided one of the applications is not very latency sensitive. And when I'm talking about not latency sensitive, in the milliseconds range. So we decided to put it on a VM. It was pretty quick. We set it up, we ran it, and for multiple months, everything was good. Then our portfolio manager started complaining that sending orders took them seconds. It's like not a little bit longer, like seriously much, much longer. So we started to investigate. We had developers look at it. They couldn't find anything. We had the network look at it. They couldn't find anything. We talked to our infrastructure that were looking at the virtual machines. And at the end, after a couple of months of investigating and trying to find what is happening, we actually found 3 different problems. One was that our CPUs weren't dedicated only for our VM, because there are a lot of VMs running on the same machine, physical machine. So we couldn't count on that CPU. Our network wasn't dedicated. It was saturated by other VMs that are using that system, therefore delaying our messages. And the last one that we couldn't see was there was a backup running on the hardware that was running the VM during trading hours, which was basically stopping our CPUs from actually working. So from that day on, we're using only hardware for our trading applications. A few more things just to talk about hardware and software that we do to reduce overhead is reduce as much of the applications that are running on the machine. Right? We segregate our operating system from our applications. So the CPU is used only by the trading machine. Same with memory. So all of this segregation, removing everything that is running on the machine, helps us make sure that there is more determinism on our application. Moving to the last layer, software, probably the most interesting for you guys and for myself. I'm going to try to talk about a couple of these. I don't think I'll have time for all. Manage or unmanaged code. Managed code is the code that is compiled and then used by another layer of software to run that code, like the JVM. A lot of benefits to using something like JVM, Java, C#, .NET. They manage all the memory for you. Memory allocation, deallocation, you don't need to worry about it. They have help with exception handling and other stuff. However, by the fact that they are managing it for you, you cannot control it. Again, the control allows you to actually have more determinism. So for example, with the JVM, the garbage collection can just start at one point, and you can't really control it. And that might halt your machine. Well, we can't have that in our applications. Unmanaged code, like C and C++, it is compiled and running directly on the operating system. It's much harder. You need to now know how to allocate memory, how to deallocate memory, make sure that you are not making as many mistakes. However, it allows you the control over the application. The other subject I wanted to talk about is the multi-threading versus multi-process. When you want to scale up your application to do more, what do you do? Well, one method is to multi-thread. Do we have the number there? No. So menti.com, and can you actually enter a question right now if you go in? No? Just a second.
It's 1530-6446.
Do you not see? You okay. Okay. Let me start with the first one. How many quants do you have? We have about 20 quant groups. So every quant group can have multiple quants and analysts that are working with them. And we have, I would guess, about 15 are externals, or maybe 16 are externals, and the rest are internal. Next question. I love this question. What's your favorite part about working at Schonfeld? One word, the people. Oh, that's actually 2 words, sorry. I love to work at Schonfeld. I love the people. I've been at Schonfeld for over 15 years now. I've seen Schonfeld changing all the way from a short-term trading firm to a hedge fund that we are today. And we have great people to work with. The culture is great. And to that, the challenges. I really, really enjoy the technical challenges that we have. Do we have time for more questions? I'm gonna try and answer this, but Radhika can help me with that one. What roles are you looking to hire? We have C++ developers, we have Java developers, we have end user services, and all of these are here in Miami. Our offices are in Wynwood. QA. What else am I forgetting? Data engineer. Yes, of course, data engineers. I'm sorry. Yes. So. Data scientists, the question is, how do you define data engineer versus data science? We do look for data scientists. I don't know if we define the location for that, New York versus Miami. I'm sure that we'll be happy to talk to data scientists to work with us even here. All right, let me see. One more? Okay. All right. Let me try and answer this one. How do you look through logs that are created in microseconds? Can you filter by that small of time frames? So when do we look in codes, in logs? Either when we have a problem, then we actually look at the time frame that we are looking to investigate, or we have programs that are looking at it. So if we are looking at creating any kind of analytics on top of our logs, how many orders were created, how long did it take us to send an order, all of that we can actually gather from the logs after the fact. So we will have a post-processing, sometimes even in real time, to understand what is happening. So we are actually looking at the microseconds. We don't have anyone that is actually watching a screen and actually looking at those. However, we do keep the timestamps up to the nanosecond, so we know what happened when. Right. I guess that is the last of my questions. So thank you, everyone. Appreciate it.
Just 5 minutes really quick, or really 5 seconds. I just want to, I brought it with me just so I don't forget. I just want to thank, of course, all the sponsors, Shonfeld, Algorand, Stream. Thank you for streaming everything for us today and recording. But also something that's really important to us as an organization is I want to thank a few additional sponsors that were able to support us with ASL interpretation to make this more accessible. So City Furniture, Consultus, Stephen Douglas, Sherlock Talent, and Centric. So thank you if any of you are in the room. I really appreciate it. Thank you. And the next sessions are getting started in 5 minutes, so you're off. Thank you. Thank you so much.